Awesome. Just to prevent any delays, I went ahead and pasted it in for you. Feel free to give it a read over. Let me know if there's any questions there, and best of luck.
Okay, thank you. So we're printing, or we're adding any smaller element to the right of each number. And if there's no smaller element, then we would add 0 in the position.
Yeah, I think that's a good description of the problem.
Okay, so I guess I'm thinking of 2 approaches. The first approach would be the brute force, where we would use nested loop, and then for each index, like go through the whole elements to the right of it. And the second approach I'm thinking is kind of use 2 pointers, and then put 1 pointer in the first, or the number that we're looking at, and then the second pointer to the right of it, and move the second pointer to the right until we get to the end. Yeah, and then pretty much once we're done with all the smaller elements to the right, we would move the left pointer 1 over, and then do the same again using the right pointer.
Sure, I think that makes sense. So what would the respective runtime complexities of each of those solutions be?
The first one, using nested loop, is gonna bring us to O of n squared. So I would, well, because we have to look at all of them kind of multiple times, like n times. We have to go through the array n times, and for each element we have to go through one loop of n minus 1 elements. So I guess the upper bound would be n squared still.
Yeah, I would.
For the second one, since we're only using pointers, we don't have to use a nested for loop. So we're going through n elements, and then there's going to be additional time, like to move the right pointer back as we go forward, through the array. But it would still be below n, so the upper bound is going to be O of n.
Sure, I think that makes sense. Could you just draw it exactly a little bit more detail of what your second solution would be then?
Okay.
I'm not trying to get the conditions in which you're moving the pointers.
Okay. So I'm gonna I don't know if this is where I would type, right? But I can't seem to be.
You know what? I see what the issue might be. Give me 1 second.
Okay.
Sorry for the switch. I was hoping we'd be able to use that one, but here, I've sent one more link over. If you could do 2 things, so 1, open that up, and 2, share your screen, that would be excellent.
Oh, sure.
Yeah. I had to convert it to a collaborative one. I was hoping it would allow me to do that without converting it, but apologies. Okay. Usually these are set up ahead of time.
No, it's okay. So inside the numbers here. So I'm just gonna call this counts. Okay, so and then if I'm just thinking.
Take your time.
Oh, so I think I'm gonna do a while loop. I'm gonna try one. Sorry. Okay, so this will be the first pointer. I'm gonna initial it to 0. Second will be, I'll just,
Would you mind walking me through a little bit what your current thought process is?
oh, yeah, I'm trying to think about like moving the pointers, like how I'm moving the pointers. So if I do a while loop and then check for a second pointer, well, both pointers actually, first and second pointers are like not at the end of the array, so length of num. Then okay, so here's nums at second is less than first. Then we add it to the result. Just gonna do results right here. I'm still gonna need a loop here. I'm just realizing now.
Yeah.
Okay. Okay, I'm gonna do I can do it. second is greater than norms at first, then we would just skip that one and increment second.
So while you've introduced the new while loop, I did want to ask: does your evaluation of the runtime complexity resolution change then?
Yeah, because so sorry, let me think for a second.
No worries, take your time.
Yeah, that's going to increase the time complexity. Going back to my thought process in the beginning, so if I don't need a while loop here. Just gonna comment this out because if we're using the 2-pointer, I could just so okay, I'm gonna think about this again. But the first pointer is gonna be 5, and then second pointer is gonna be 2. I will add 2, and then the first pointer will stay here. The second pointer will go here. I'll check again. I will move without adding, and the second pointer will be here, and this will be added.
So I guess my really direct question here is just under what conditions are you moving the pointers?
Whether or not they're smaller than the first pointer, the element in the first pointer.
Okay, so you advance the second pointer whenever it's larger than the value at the first pointer, or whenever it's smaller?
Well, so both. So I'm advancing the second pointer and keeping the first pointer in place until I reach the end. But I would only add when it's smaller than first pointer. And if it's larger, I would just skip it without adding. And then once the second pointer hits the end, I would move the first pointer to the right to check the second number. So I don't need a second while loop. I'm sorry. I think that's the confusion.
I think that would be functionally the same as the brute force approach. If you're just going to say start at 5, go through 2, 6, 1 counting, start at 2, go through 6, 1 counting, start at 6, go through 1 counting. That sounds the same as the brute force approach, even though you are using 2 pointers. So in that case, it would be n squared still.
It would be n squared. Okay.
Yeah.
Well, I guess I'm thinking.
So I will go ahead and give you a bit of a hint here since we have, I think, only about 20 minutes left. So the solution does involve essentially implementing a sorting algorithm, um, or at least implementing something very similar to an existing sorting algorithm. And I'll also say that the optimal runtime here is n log n, is the fastest that you can do it.
Okay. Um, okay, let me think about this again. So,
So could you just walk me through some of the current thoughts you're working with? It doesn't
um,
have to be particularly correct or anything.
I'm still trying to think through how I can use a sorting algorithm. Um,
So I would recommend just thinking about the runtime complexity I mentioned as a good starting point.
okay. Can we maybe use like heap?
So a heap would be similar, I think, to the right solution here, but specifically what we'd be looking for is it might be possible to implement with a heap, but I think it would be pretty difficult. Um,
Okay.
I would suggest if you can think of any, roughly n log n time sorting algorithms, specifically any that would tell you about maybe smaller elements in an array, really specifically talking about things that are that kind of comparison of smaller to larger elements, and you might be able to use that algorithm in order to kind of pseudo sort them and then be able to essentially check um, you know which one's smaller or which one's larger, and then when you do that check you would be able to sort of use that to assemble your counts array. So
Okay.
can you name any particular sorting algorithms that might be n log n time?
Um, I'm thinking like divide and conquer algorithms.
Yeah, that
Uh,
would be along the right route.
so like merge sort, for instance, but
Mhm.
um,
So what would be your
okay.
thoughts around using merge sort for that?
Um, I'm trying to think like how we can only look on the right side.
Sure, I don't quite know what you mean by looking on the right side.
Because we want to, well, the question says we just want to look at the right side of the like of each element and like find the smallest or the smaller element on its right.
Mhm. Yeah, so I think it that is correct. Um, I think if you really think about how merge sort works, there would be a
Mhm.
time at which you would be kind of doing that comparison. Um, and I think merge sort is a correct approach, and you would be able to essentially um, assemble all of the information you would need to
Mhm.
solve this problem in one pass of merge sort.
Okay.
So I would think about using merge sort and then sort of adding, you can think of it as logging or tracking to it, where when specific things happen within your merge sort, you're going to keep track of those in some kind of data structure. Um, and then that will be your output. So I would think about it like that.
Okay. Um,
I think what might be helpful to start is just realize we only have about 11 or 12 minutes left, but just kind of implementing merge sort to start and kind of thinking about how it works. And that might give you some insight into how you would solve this.
Okay. Okay, so merge sort, we typically look at the middle element. Well, we would kind of divide in the middle and then look at the left side, or sort the left side, and the right side, right? So I guess, yeah, that's where I'm a little bit confused, I think.
Yeah, so when you think about merge sort, it's not necessarily that you are doing recursive calls. So when you get to the bottom, you start by breaking it, essentially you can think of the logic. It starts by taking your whole array and breaking it into the left side and the right side, and then breaking that into the left side and the right side. But then when
Yeah,
you're at the bottom of the recursive structure, it's just each element for its own.
yeah,
And then for each element, you're essentially combining the two and putting one on the left side of a subarray and one on the right side of a subarray. Um,
yeah.
and you're kind of figuring out where these elements fit in. So I think you can get some information there about which element is going to be smaller than another one.
Okay. Um, oh, okay.
Does that make any sense?
Yeah, I think I understand what you're saying, because once we get to the individual elements, then we would make the comparison of
Mm.
like which one. But I guess what I'm confused about is like, how do we know which one is to the right side of each element if we when we get to the bottom?
Mm-hmm. Well, the merge sort works essentially in place. Um,
Oh, okay.
so it's going to maintain the order of all of the elements from the original, um, from the original. Or you could just what you could actually do that would make it easier would probably just be, storing that information along with them. So you could have something like, instead of doing merge sort in the original list, you make a list of tuples, associate those tuples one with its original position in the array, and then its value, and then you sort that.
Okay. So like use a okay. Okay. Let me start over. Okay, so I'll call it I'm sorry. And then so the merge sort. To start and end. I can't do paste. Oh. Okay, so if it's an empty array, then we return it to or greater than returned. So we would pick the midpoint and then we would do recursion to at the left and right side. Numsat start to midpoint and then this one and um so then I guess we would do the comparison before the merge stage.
Yeah, I would agree.
Okay. Or we do it as part of the merge, I think, right? Like,
yeah, so I think the way you would want to think about it is that we are doing all of the splitting recursive calls first, getting to the bottom, and then looking at this logic. Once we have both sides essentially moving into the merge.
Yeah. Okay. Then
All right, we've just about hit time, so I'm okay calling it there.
Okay.
But yeah, good job on getting it to the end. I know this was a hard interview, um, but I'll go ahead and just give some initial feedback um, on general things, and then I'll leave you some space to ask me some questions if you had any.
Okay.
So, also deep apologies for the technical issues during the beginning of the interview. I know there was a couple there between you know having some Zoom instability and then also the weird codebunk link. Um, I'm sure that definitely didn't help. So, other than that, feedback on the actual interview. So, I think um, I think a good place to start is definitely just communication. Um, I think that aside from any technical problems or anything like that, there's definitely some space that you have to work on kind of communicative skills. There was definitely a lot of just silence during the interview. Um, and I do think that you came to some reasonably good ideas, especially I think, although it didn't end up working, I think using 2 pointers is a good idea. Um, it doesn't quite work for this question just because there is sort of knowledge further on in the array that you need that you're not able to just get to without, essentially looping through the entire list.
Mhm.
Um, but I do think that was a good idea. I think it's just that it wasn't communicated super well initially. Um, so I wasn't able to sort of, as the interviewer, step in and be like, no, that doesn't work for this or this reason. Um, and then we would have quickly moved on to other approaches. Um, but yeah, I think just working on figuring out how to think with the interviewer, if that makes sense. Because currently, I definitely felt like you were kind of, working inwardly and thinking through things, but not really able to vocalize it. So I think just working on, even if you're taking interviews, practice interviews by yourself, just trying to talk the whole time. And I think a good goal to shoot for, a good like practical one, is not being silent for more than I would say 20 to 30 seconds at the time. So that
Okay.
does need to be pretty constantly talking throughout the whole interview. Um,
Mhm.
but I think just starting with the goal of I'm going to say anything um, is a good stepping stone to getting to the point where you're really vocalizing all of the thoughts that you want to. Um,
Okay.
I would honestly say that's a big thing. As for the actual technical problem itself, obviously this is kind of a hard one. I definitely, as a policy, make all of the like domain specific interviews tend to be more difficult than the general ones. So for the data structures and algorithms interviews, I
Mhm.
generally just run them at a medium lead code level, sort of easy to medium. And then for specific topics, I tend to run them at the medium or hard level. So this is one of the harder lead code questions. Definitely,
Okay.
it relies on your knowledge that this is a sorting problem. Um,
Oh, okay.
because yeah, if you go into the
Because I
interview,
already knew. Yeah.
yeah. So the kind of gist of it is knowing that you're going to an interview that has to do with a sorting problem, and then that's how I expect someone to be able to find out how to use, that they have to implement merge sort. Um, Otherwise, I wouldn't give this because I think it's a little too obscure. Um, but yeah, I think what the key problem that a lot of people have this problem is not being able to visualize it correctly. Um,
Yeah.
and I'll link you the problem yourself so you can look at some solutions afterwards. But once you learn how to visualize it, it's actually really not that complicated. Once you are able to have a picture in front of you of the um, kind of arrays coming together, um, it's essentially just whenever when you're working on merge sort, you break them down into individual boxes and you put the boxes either on the left or on the right. Um,
Mhm.
if you put it on the left, you've just put a smaller element. You've just taken an element that was smaller in front of a number. Say you have the string just something like 4 5,
Mhm.
um, or sorry, say you have the number 5 4. If you take
Mhm.
the 4 and put it in front of the 5 in your merge sort, then you've just said I know a number smaller than 5 that happened after it. So that's it. It's just whenever you take during the merge, whenever you take a box and you put it on the left, that's an inversion.
Okay.
And then you increment everything it skipped over essentially. Uh,
Okay. Yeah, that makes sense when you put it that way. I guess I was like stuck on the point of looking at the right side of the original array.
mhm.
That's kind of like where I got stuck, I think.
Yeah, that totally makes sense. No, it's just knowing about that, and it is a pretty specific thing to know about scoring algorithms. Yeah,
Okay.
I would say those were the 2 points of high level feedback, both on the behavioral and the technical. So if you had any questions for me, happy to answer them now.
Yeah, so I have a question. Um, like I realized that I was quiet a lot because I did get stuck a couple of times. So I
Mhm.
guess my question is, if you're stuck and not necessarily um, like have few options like right away, then how do you recommend, communicating that, or like um what do you say, or do you just like say anything, or like how would you um like what
Yeah,
would your advice be, I guess, in that case?
yeah, definitely. So I think it depends. Obviously, there are, I think, different phases of being stuck. So there's kind of the um, being not sure what to do in the current situation, but you think that your approach is good. Um,
Hmm.
if you think that you're on the right general approach, but have just run into a wall or something, like for example, when you were working on the 2 pointers and weren't sure what the conditions should be, um, that's something that I think is mostly due to you having not thought through it enough. And I don't think that's something where you need to have the interviewer step in. I think it's more just a um, that seemed more like a nerves thing. So what I would do is just map out, just go back to the very basic of your approach, ignore the code implementation and just be like, all right, what am I trying to achieve with this? Um, and then really think about it. I think if you're stuck in that you don't think your current approach works and you're not sure what another approach is, that would be
Hmm.
the time I would kind of zoom out and try to think about every relevant topic that could be appropriate to this question. Um, I think what people do when they find that they've run into an approach that doesn't work, say you've spent 15 minutes in an interview working on an approach that almost seemed like worked, and then after 50 minutes, you're like, it doesn't work at all. Um, People tend to look only for very similar approaches.
Yeah.
Um, you tend to tunnel vision and be like, all right, there has to be a small modification I can make to this to make it work. Um,
Hmm.
I think the opposite approach is better. I think immediately just start talking about like completely different approaches. So, for example, knowing that this is a sorting algorithm, just start listing sorting algorithms and be like, okay, could I do a bubble sort, a heap sort, a quick sort, a merge sort? Um, and even if you don't have time to explore all of those options, I think jumping to something completely different can be really helpful. And then finally, if you've really gotten to the point where you've zoomed out and you've explored a lot of options and you've taken a lot of time and you just have no idea, um, honestly, I would say I would just ask the interviewer. I wouldn't ask it so directly as I'm stuck, I need help, but I would say something along the lines of, yeah, I don't think my current approach is working. Do you have any thoughts on what a better way to use this logic would be? And then you just ask. Because ultimately, there's definitely a point at which if you're confident that you're not going to be able to find any other options, um, it's way better to ask the interviewer for help and instead of just kind of giving up on the interview essentially. Um, because uh, obviously all interviews kind of have this spectrum in their heads of like um, I guess it's not obvious, but all interviewers essentially have a spectrum in their heads of how much hints they can give, because ultimately it is a collaborative thing. So there's going to be some interviewers who are going to say, I guess all interviewers are essentially going to say, here's the line. If I give this hint, I can't pass them. Um, but you're entitled to all hints up until that line. Um, so if the interviewer hasn't given you that much feedback, they probably can give you a lot more before they decide that your solution isn't enough your own that you can't, pass. Um,
Okay.
So definitely, try keeping track in your head a little bit of, how much information has the interviewer given me? And you're definitely allowed at least once per interview to be like, hey, my current approach doesn't appear to be working. Do you have any recommendations? They're not going to immediately, give you a hint so large that they have to disqualify you. They're going to work up to that.
Okay.
Yeah.
Thank you.
Cool. Sorry, I know that was a bit rambling. Did that answer your question?
Yeah, it does. Yeah. Thank
Awesome.
you.
Great to hear it. Cool. Well, we're just about out of time. So I'll try to send a more detailed feedback spreadsheet your way in the next day or so. So be on the lookout for that.
Okay.
And otherwise, I'll also send over. I suppose you already have it because you had to email me. Um, but feel free to email me with any questions. Feel free to reach out there with any questions, either about this interview or about the process in general.
Okay. I will. Thank you so much.
Awesome. Yeah. Thank you too. Have a good rest of your day, night, whatever it is. Thank you so
Okay.
much.
You too. All right. Bye.
Bye bye.